right, so let's talk about percent composition, right? Percent composition is slide gets cut off, whatever. All right, so every single element is made out of, or every single compound is made out of a percentage of certain elements. I believe an example I gave way back when was copper. No, sorry, it was it was copper carbonate. It was copper carbonate. How scientists basically, no matter the amount of a substance, no matter what amount of a substance, when they broke it apart, it always came up into the same proportions. That's where the law of definite proportions came from. They're like, well, this compound's going to be a certain percent copper, certain percent carbon, certain percent oxygen, regardless of whether you have 1 gram or 10,000 grams. All right. Well, that came from this calculation of percent composition. So what is percent composition? Well, the percent by mass is equal to the mass of the element over the mass of the whole compound multiplied by 100, so you can get a percent. Now this formula is relatively simple. It is relatively simple. Get away, thing. You were from last video. All right. So what we're going to be doing now is we're going to be looking at, let's say, the percent composition of this substance, or the percent by mass, the percent by mass of this substance. So what you need is the mass of the element in the compound. So let's say we are looking for the mass of iron. We want the percent of the percent by mass of iron inside this compound. Well, what we do is we need the mass of the compound at the bottom. So what we do is we get the mass of 2 irons. So the mass of 2 irons is 55.85, I believe. And then the mass of 3 oxygens is 16. And over here, since we want to find iron, we put the mass of iron in there. And there's 2 irons in this substance. All right, let me just double check the mass of iron. I don't know it off the top of my head. 55.845. Good enough. That's good enough. All right, so we just do this in our head really quick. Not in our heads, in our calculators. Or your head, it don't matter. So you get 111.7, or if you did... or 6.9 if you didn't round. And then we're going to add 48 to it, and that's going to be 159.7 at the bottom. And I forgot to write the times 100. I'm a bad student. I'm a bad student doing all my work. Do you not pay attention, Mr. Sanchez? Do you not pay attention to what I say? All right. So here we have it. So we get 111.7 divided by 159.7 multiplied by 100, and we get 69.94% of iron. So this compound, majority of the weight comes from the iron. 70% of the weight from this compound comes from the iron. All right. This is how they're able to measure the percent composition of the atmosphere, right? You don't need to weigh out all of the particles in the atmosphere. You just need a small sample, find out the percentage of each gas in there, and then you know what our air is made out of. But let's take a look at the problem from here, right? So let's check this out. So let's consider the chemical compound limonene, which occurs in 2 forms known as D-limonene and L-limonene. That has to do with mirror images. Don't worry about that later. I'll talk about that later. Both forms have the same molecular formula, C10H16, but different arrangements of atoms. The D-limonene form gives lemon peel its characteristic smell, while the L-limonene form is responsible for the smell of oranges. Ooh, interesting. I didn't even know that. All right. All right. So from the first thing, what do we know in this problem? Well, we know the elements in there, right? We know that we have 10 carbons. We know that there are 16 hydrogens. And we can get the molar mass of C10H16. All right. And that can be, we get 16 times 1.01. And that's easy. That's well, let's write it out. It's 16.16 AMU plus the mass of 10 carbons, so 12.01 times 10, that's 120.1 AMU. We add those two numbers up, we get 136.26 AMU, and now we have the mass of C10H16. What information do we need to know? Oh, we need to know the molar mass. I think that's what we needed right here. We needed the molar mass. So to show some work, very, very simple. Let's do the percent by mass of each element, right? Each element. So we need the percent of carbon and we need the percent of hydrogen. Well, remember the formula. Since the molar mass is the same, we know that it's going to be 136.26 AMU at the bottom for both. So we set up both problems all at once. At least that's the way I like to do it. Some people like doing one at a time, but if it's the same calculation, I like setting them up all at once and then just doing the math. Now, the percent of carbon, right? Well, there was 10 carbons, so you do 10 times that 12.01 AMU. And then over here for hydrogen, it was 16 times 1.01 AMU. All right. Now, you just put this in our calculator. We've already done the math for those. It's up here at the top. So what I'm just going to do is, for the carbon, I'm going to do the 120.1 divided by 136.26. And I always forget to multiply by 100. Do not forget that. Do not forget that. So right here, this one is 88.14%, 1.4%, and then the other one is 16.16 divided by 136.26, multiplied by 100, and you get 11.86%. Now both of these should add up to 100. So if you do this really quick, 11.86 plus 88.14, you get 100. So this is the percent of hydrogen, and this is the percent of carbon. So if, let's say you got orange peels, right? And you wanted to find out, or you isolated that smell of citrus in a tiny little vial, and you went to a mass spectrometer. The mass spectrometer will show you a little graph where the masses will be off on the side, and then where your mass would be right here at the bottom, where the mass of the hydrogen, that 1.01, you'd see a peak. That's about 10%, or 1/8. It's going to be 1/8 the size of that carbon. So around 12.01, you'll see a peak of that carbon. So the ratio here, this is going to be about 8 times as big as that. And you'll get these percentages, right? So you'll know the formula You can kind of work backwards if you wanted to determine. That's how the formula was determined. We're doing it in reverse, but when you go to the big girl labs, big people labs, you do the experiment and then work backwards to figure out the formula, okay? And you do it by getting that sort of data. I don't know if that confused you a bit, but it's just a source of where you get these types of problems. Now what you got to do is just find the percent composition of each element, or the given element in your problem, all right? And that's basically it. Farewell, people. Farewell.